if you want to simplify square root expressions, so now incorporating some variables, like here we got an x squared and x squared y down here, the principles and how square roots, that doesn't change, right? It doesn't matter if it's numbers or letters, so just be careful with it, but we'll walk through some examples, and I think you'll get the idea by the end of it. So here I got 81x squared, or 81 times x squared. So from our last video, where I know that I can separate those two and give each of those terms its own square root. So the square root of 81, well, that's 9. And the square root of x squared, what times itself is x squared? Well, it's just x. X times x is x squared. So 9x is our answer. And if we take 9x and square it or multiply it by itself, we're going to get 81x squared, which is exactly what we started with from the beginning. Same thing for this next one, square root of 400x squared y. Just give each of those three terms their own square root. So we'll have square root of 400 times square root of x squared times the square root of y. Square root of 400, well, that's 20. Square root of x squared is x, like we saw earlier up here. And the square root of y, right, we can't reduce that any further. So we're just going to leave it as the square root of y. And there's your answer, 20x root y. And if you square that, you will get 400x squared y. Square root of a squared, b squared, c squared, right? Just give each of them their own square root. But probably at this point, or hopefully at this point, you don't need to do that, and you should kind of recognize the pattern. Square root of a squared is just a, square root of b squared is b, square root of c squared is c. And again, if I take abc and multiply it times abc, well, I'll have a times a, which is a squared, b times b, which is b squared, and c times, whoops, that should have been a c. C times c, which is c squared, which is what you started with at the beginning. So when you have variables that have exponents that are higher than 2, because that's all we've done up to this point, here's the trick. So if I take this one, for example, square root of x to the 8th, I'm going to take my exponent, I'm going to divide that by 2. Right? Later on, you will understand why this works, but for now, just want to get the homework done and go on and do other stuff. So take your exponent, divide it by 2, and that becomes your new exponent. X to the 4th, the square root of x to the 8th is x to the 4th. If you don't believe me, take x to the 4th times x to the 4th. You just need to remember your properties of exponents, right? When you're multiplying two terms that have the same base, you just add the exponents. So 4 plus 4 is 8, and we have what we started with. But wait, they'll say, what if my exponent inside the square root is an odd number and it's not evenly divisible by 2? Well, you're going to divide by 2, but before I do that trick again, let me kind of show you the long way so you can see that, and then we'll do the shortcut. So what if I did this? What if I rewrote a cubed as a times a times a? And then what if I rewrote that just multiplying those first two terms? Well, I'd have a squared times a, or the square root of a squared times a. Well, since I'm multiplying these two terms, I can give them their own square root. So I'll have the square root of a squared times the square root of a. Square root of a squared, right, is just a. And then the square root of a can't simplify that any further. So we'll just leave that be, and that is going to be our answer. So now doing it the shortcut way, just divide by 2, right? So we're going to do 3 divided by 2. 3 divided by 2 is 1 with a remainder of 1, okay? So what we're going to do with that information, this first one, that's going to be the exponent of our variable on the outside. So we'll have a to the first, or just a. And then the remainder, right? Remainder of 1 is just going to tell us, hey, put another square root of that variable, whatever it is. So we'll have a square root a, just like we did the previous way. So again, y to the 7th, it's an odd exponent, so I'll do it both ways again. First way is, let's just do about y times y times y times y times y times y, one more, times y. Okay, And I'm going to multiply those first 6 y's together, and I'll get the square root of y to the 6th times y. All right, split those up. You'll have square root of y to the 6th times square root of y. What times itself is y to the 6th? Well, here, since it's an even exponent, you can just do that divide by 2 trick, and we'll get y to the 3rd, and then the square root of y, can't simplify that any further, so we'll just leave it be, and that's our answer, y to the 3rd root y. Or you can just take that odd number exponent, divide it by 2 anyway, right? 7 divided by 2 is going to be 3 with a remainder of 1, so that means we're going to have y to the 3rd, and then the remainder of 1 just says, hey, throw another square root of whatever variable you had. Same exact thing as we got the previous way. The square root of z to the 100th power, right? It's an even number, so just divide it by 2 and be done with it. 100 divided by 2 is 50, so our answer is z to the 50th. All right, let's try a couple harder ones. So here, since I'm multiplying these 3 terms together, I'm going to split them up and give them their own square roots. So square root of x to the 6th times square root of y to the 5th times the square root of z to the 4th. All right, these two, since they're even numbered exponents, can take care of those super easy, right? We'll have x to the 3rd, and then we'll come to this one in a second, times something, and then times z squared, right? Just divide those even numbered exponents by 2. Here, I'm still going to do that, right? I'll divide 5 by 2, which is going to give us 2 with a remainder of 1. So that means the answer is going to be y squared times the square root of y. Right, now we just combine everything back together. And we'll have, let's do x to the 3rd. We'll have y squared. We'll have z squared. And then at the very end is where you throw your terms still stuck in the square root. So there's your answer for that one. All right, similar thing here, just 4 terms. So just split them up, give each of them their own square roots. We'll have square root of 144 times square root of a times square root of b to the 10th times square root of c to the 7th. The square root of 144, should know your facts, that's 12. 12 times 12 is 144. Square root of a, we're going to leave that alone because can't simplify that. The square root of b to the 10th, just divide that by 2, and you'll get 5. So that means this will be times b to the 5th. And then same thing here, 7 divided by 2, that's going to be 3 with the remainder of 1. So our answer there is going to be times c to the 3rd times the square root of c. All right, just combine everything. We'll do the ones outside of the square roots or that don't have square roots first. So we'll have 12b to the 5th, c to the 3rd, and then everything else that has a square root, I'm just going to lump it all together under 1 since we're multiplying. So it'll be square root of a times c, like that.